and net zero, and his talk is titled Nuclear and Net Zero. What does net zero carbon emissions by 2050 really mean, and the untold part nuclear energy can play? At the end of his talk, I will come up to the front again and we will take questions for Robert, and we will talk about that a bit more at the end. But thank you, Robert.
Brilliant. Am I on? Yes. Evening, everyone. It is great to be here and great to be with you. For those that don't know me, I have a passion for science. There's me as a 9-year-old in the garage having fun doing chemistry. This then led to me heading off to, oh no, I missed a bit there. When I was in year 9, so 13, 14, a company called Urenco, who do nuclear enrichment, came into our school and spoke to us. I'd always known that you had to burn stuff to create heat. Heat turns a turbine, turbine electricity. I got that bit. And then when the company came in, you can collide chemistry. I know it's not quite like that, now I work in the sector, but collide chemistry and make energy, which is effectively what nuclear fission is, which is where you have your uranium and you spit it. I thought, I want to do that. So I was very lucky from the age of 13, 14, I knew I wanted to go into the nuclear industry. So I went off to Loughborough, studied radiochemistry, which is nuclear chemistry at Loughborough, then entered the National Nuclear Lab 10 years ago, and then, as Grace said, last July became the youngest fellow of the Nuclear Institute. In terms of a path I've been on in 10 years, there's just a few pictures. I do a lot of work with schools, talk to schools, inspiring young people into the sector. So I thought I'd also use that picture there. You've got me graduating there, my brother one side, mum the other side, then kind of going into the world of work and various sort of awards and things. And then last year, I managed to release 2 publications all about the UK's facilities, capabilities in the area of nuclear. So that's a bit about me and why I'm here and so passionate about nuclear. Tonight, I'm going to talk us through a bit about COP26, which Grace mentioned earlier, and then going into energy, the challenge we face, and nuclear. So, COP26 in November 2021 up in Glasgow. I was very privileged and honoured to be able to go up there and be in both the blue and green zones. I'll explain what I mean by that in a second. So, the green zone is the public zone. So, you could get a ticket to go free into the zone and view all the various stalls and stands that were there. So you had sort of the Sainsbury's, the water people, etc., and a few energy people. So Rolls-Royce were there, they had their plane outside, and I went up to the person and said, what do you know about Rolls-Royce nuclear? She got her notes out, and she read word for word what it said. That's all that she knew about nuclear. I then went and spoke to Scottish Power, Scottish SSE, and various other National Grid and people. And you can see a model they had there of an energy system. Nice wind turbines, nice solar. What I asked about nuclear, they didn't know anything. The only nuclear bit inside the actual green zone was the stand you can see there, the cubes, all about fusion. So there was no one manning these stands. There was 2 cubes there talking about, if you stood there long enough, about nuclear fusion. That's where you take elements and stick them together, whereas fission is where you take uranium and split it up. Fusion's about 40 years in the future. But what I'm trying to say here is, from a public point of view, at COP26, the only real presence we had educating people on nuclear was 2 stands, or 2 boxes with no one manning them. When it comes to the more important zone, you could say, for the actual leaders, the policymakers, those making decisions, there was a bigger nuclear presence. So in terms of Nuclear for Climate, that's what I was there as, an international coalition of 150 organizations from across the globe, and the International Atomic Energy Agency attended for the first time as well, and we'll hear from Director General Grossi in a second. Rosatom, the Russian Federation, had a nuclear reactor, which is the 3rd picture along there, and the UK Pavilion, that's just kind of what we called them there, they had a number of nuclear talks as well. So a lot more is happening in this blue zone, and what's going to come on the screen now is Director Grossi, so the head of the International Atomic Energy Agency, was on a panel discussion, and he was asked about nuclear, as you can imagine, and this is what happened.
Sorry to say, you say no one died from radiation in Fukushima?
No. I don't know why you're laughing. It's a fact. It's a fact. Thousands of people thousands of people died because of the tsunami.
Right.
But there were no deaths attributable to exposure to radiation. People died also because of the evacuation. It was very traumatic, very serious thing happened. We are not banalizing. We are taking this very seriously. This
Right.
is not a laughable.
I think the laughter came because
it's a
that's
dramatic thing that happened.
yeah. I think there is probably some scope for disagreement there because I think the Japanese media would disagree with part of that, with all due respect.
No. The facts are the facts. The facts are the facts, and this has been recorded. There's also the records from the United Nations Scientific Committee on the Effects of Atomic Radiation that has confirmed this. It's not the IAEA. So, but again, it's not about saying nothing happened. It was a very serious accident with very serious consequences, and no one should deny that. We are not in the business of denying these things. What we need to do is to look at these things objectively and with the science and with the facts and make the most and the best out of it.
Right.
So as you can see, he got laughed at by the audience because he said what the facts were. The person who interviewed him did actually go away, and the next day a national newspaper apologized because she did her research, and nobody has died from radiation from Fukushima. And as Grossi said, it was extremely traumatic. A lot of people did die from the evacuation. But the media would have us believe people died from the radiation. This is the stigma that nuclear has, and the same in the news. If somebody happens to get burnt because of a scald on a hot pipe at a nuclear station, it's headline news. That happens every day. There's somebody in industry getting burnt on pipes and things happening. But nuclear, it sells the newspapers. And tonight we're going to come into a bit more detail about what nuclear can do and how I'm trying to kind of get rid of that stigma and help people understand what nuclear can do and what nuclear has to do, in my opinion, going forward. So what was I doing at COP? Good question. So the arrow there is me on the Nuclear for Climate stand. We were 150 of us over the 2 weeks. We're there talking to people coming through, the politicians from various countries. So I had people from the developing world saying, we don't even have electricity 24/7. What can you do to help us? And I'll come on to that later on. We also had senior people, so you've got Sir Patrick Vallance there. You can't, because we've got our masks on, it's hard to tell, but that's Patrick Vallance in the top, and the top left is Bear Grylls, the chief scout. We had various people coming up, and we were helping people understand and educating them all about nuclear energy. We also had a flash mob, and at the end of the talk, you will get to watch that. That had over 240,000 views of this flash mob that we did in Glasgow in the middle of the high street. We also had an inflatable, huge gummy bear called Bella. There's me stood with Bella. She is huge, but she was also an attraction that people were coming and saying, why have you got a gummy bear? And the answer is in this video.
So if this gummy bear was made out of uranium, how much coal would you need to produce the same amount of energy?
A few kgs, 5 to 6 kgs.
What if I told you it was 1 ton?
What? I can't believe that, really?
Yeah.
So that's just going into the energy density of nuclear fuel. So a normal-sized gummy bear, so not much more than a rubber on a pencil, is the same amount of energy you can get from that as a ton of coal. And obviously coal, as we know also, is carbon emitting. And you can see the shock that chap had when he found that out. So again, we are helping educate people while we're at COP on what nuclear can do. So moving on from that, I thought I'd just go a bit about COP to start with, and it links to what Grace said. Net zero carbon emissions. We hear climate change, net zero carbon emissions a lot, but we don't often actually unpick what that means. Now, I could give you a talk for 5 minutes, but I've talked long enough at this precise second. You get another 20 minutes. Yeah. So this is done by CAFOD. CAFOD are a Catholic charity. It's actually designed more for children, but I find it quite an engaging way of sharing what climate change really is. So it's about 4 minutes, and you get to hear.
Climate change is happening, and it is changing our world. Every time we burn fossil fuels like coal, oil, and gas, they release greenhouse gases into our atmosphere. These gases are causing our planet to get warmer. And when our planet gets warmer, we will see more extreme weather events, more droughts, and more flooding. Scientists have told us what we need to do. We must stop adding to climate change. Because if our planet warms up more than 1.5 degrees, climate change will leave more people hungry, cause more floods, and millions of people around the world will have to leave their homes and move somewhere else. To stop adding to climate change, we have to reach net zero emissions. Net zero means keeping things in balance. It means cutting the amount of greenhouse gases we put into the atmosphere and replace old polluting technology with new greener technology, and making sure that any gases we do release can be removed, for example, by planting more trees that lock them away. It's not easy, but it can be done. It will mean working together to build a safer future for everyone. A future where we power our schools with new green energy. We power our homes with solar panels. And we switch to environmentally friendly cars. And we eat less meat. These are just some of the ways that we can care for our common home. For these changes to happen, we must raise our voice and tell people in our government that we really care about our future and that climate change matters to us. Because by working together, we can look after our beautiful world and help build a brighter future for everyone.
So yeah, that kind of is another voice rather than me constantly talking at you with my passion. Greenhouse gases aren't a bad thing, is the key thing to mention. We need almost this duvet cover around the planet. The sun sends nice heat to us, we all like the sun. If we didn't have that duvet cover of greenhouse gases around the planet, all of that heat would effectively escape and the Earth would be too cold to sustain life. So we do need this level of duvet cover around the planet, and we need to keep that in some ways as it is. But the issue is that sorry, I missed out a bit here. We need to keep that as it is. So in terms of the carbon cycle, so you might remember back at primary school and senior school, have these cycles and water cycles and things. This is a carbon cycle of, you've got your trees, and they obviously absorb carbon dioxide. You've got things going down into the ground, so think about your fossil fuels, how all that carbon is locked away. That's all great. The problem is at the moment is we're doing a lot more of this side of the chart. We're digging up all that fossil fuel, all that locked away carbon, and we're then releasing it as a gas into the atmosphere. And then we're not capturing it again enough to then lock it away. So we're getting more and more and more and more and more and more and more carbon and greenhouse gases going into the atmosphere until our duvet cover is getting thicker and thicker and thicker and thicker. The planet's getting warmer and warmer and warmer. And as we've seen in the Christian Aid videos and in the one I showed, this heating the planet is causing extreme weather events, extreme droughts and extreme flooding. So the challenge is we need to keep, or actually reverse slightly really, but keep is that would be efficient, our current level of carbon in the atmosphere and stop releasing all the extra stuff that's in the ground locked away at the moment. Chemistry lesson for you all. First of all, how do we get these fossil fuels? So millions of years ago, organisms die. They settled down to the bottom of the sea. Silt lies on top of them. You've got water pressure. Over a long time, this forms fossil fuel, effectively crude oil sat down there. We then suck that crude oil up, and we then put it through fractional distillation, GCSE chemistry. And that then gives us gases. So all your houses have a gas pipe to them, fossil fuel. It gives us petrol, or octane. You may have heard it when you think octane mating of your petrol. We burn that. It gives us our jet A or kerosene for our planes, and it gives us heavy fuel oil for our ships. So that carbon that was locked away, we're then having that turn into a liquid to start with, and that liquid is then being released to the atmosphere. To actually use an example here of a chemistry equation, octane plus your oxygen releases water and carbon dioxide. So every single molecule of this fossil fuel we're burning, we are then releasing all that carbon dioxide going into the atmosphere, and it's sitting there. The duvet cover is getting bigger and bigger and bigger. Now, you might all be thinking, but we've got all this renewable energy, we're sorting electricity, but why do we need to think about nuclear? Can't renewables do it all? Electricity is 18% of energy demand. The other 82% is heating and transportation and industry. 85% of our homes have gas central heating. We are taking that carbon that was locked away, and we're then burning it and releasing all that carbon dioxide into the atmosphere. Transportation-wise, again, we all know how much we jump in our cars, how much we move around now. And as an example, in 2022, 898 billion pounds worth of imports came into the country. We import all that, the shipping. To give an example from air freight, you can see here, that's too small for me to read from the back screen, 23.8 million flights in 2004. The predicted for 2020 was 40.3 million, almost doubling in 15 years. That's almost doubling the amount of carbon emitted from the flights in those 15 years. It's a culture that we're getting used to. We want to go on holiday abroad. We like that freedom. We want to be able to get all our different fruit and veg all year, not just when you can grow it in the UK. We want to be able to heat our whole home. We want. And that's the culture, and especially my generation are growing up with the expectation that we can do what we want, travel where we want, in whatever form of transport we want. But it is damaging the planet, this, and you can see just in 15 years how we doubled the atmospheric pollution from our flights. So what's the summary of this? We are extremely reliant on fossil fuels, and I'm going to go into in a bit more in a second quite what that scale of the issue means compared to electricity. Now, that's the developed world, and in the video we heard about the developing world. Now, this graph looks great, and it is great. We are seeing the number of people with access to electricity in the world drop by more than half between 2020 and 2021. Brilliant. The biggest decline was in the developing Asian regions, whose population without access dropped by nearly 90%. Brilliant. Little change, however, in sub-Saharan Africa, where access accounted for 78%. This all sounds brilliant. However, in 2015, coal supplied 36% of Vietnam's electricity. The US predicted in 2018 it would be 56% by 2030. In 2018, Kenya, Nigeria, and Ghana all announced new coal-fired power plants. The government said that the economic benefits associated with the stations far outweigh the negative effects. The irony is they didn't have enough water for their hydropower. The reason they are building more fossil fuel stations is because they couldn't get enough water because of the climate change for their hydropower. They are building fossil fuel powered and emitting power generation for their country. Air knows no boundary. We can get to net zero, great. But if Vietnam's not net zero, then the air around our planet, that duvet cover, will still get bigger. Now, in the video, we heard from Christian Aid about the developed world needs to support, and that they weren't, and they are now starting to. So, the end of December last year, the Vietnam's Just Energy Transition Partnership was released on the government's website. What did this say? This political declaration on Vietnam's Just Energy Transition Partnership was agreed by the government of Vietnam and the International Partners Group, and the group included the United Kingdom, France, Germany, United States, Italy, Canada, Japan, Norway, and Denmark, a number of the developed countries. Now, the partnership was to mobilize £15.5 billion of public and private finances to support Vietnam to achieve its ambition of net zero 2050. And Vietnam, to do this, transitioning away from fossil fuels. So that's great. What I was going through on that last slide and the commitments made in 2018, look what's now being committed by the developed world to support with that net zero by 2050. That's just an example to show what was discussed in the video of how the developing world is supporting the developing world. Right, nuclear. I've discussed now COP26. I've discussed a bit about the energy challenge we face. I've discussed a bit about the developed and developing world. How can nuclear help? At the moment, this is what nuclear does. As I mentioned at the start, electricity. We take the nuclear fuel, we generate heat from it, that heat turns a turbine, electricity goes to the grid, and it heats, or powers lights in our buildings and some electric cars. This is what nuclear can do. And I'm going to go through a few examples of them. Clean water. 1 in 10 people do not have access to safe drinking water, and 2/3 of the world's population experience severe water scarcity during at least 1 month of the year. Nuclear energy can take seawater and it can desalinate it, so it can make it clean, drinkable water. Nuclear energy can take water, it can split it to oxygen and hydrogen. Water, H2O, get your hydrogen, oxygen. Hydrogen can be a fuel. Nuclear energy can be used to suck carbon dioxide, direct air capture. You may have heard, if you listen to Radio 4 a lot like I do, Climeworks have been discussing direct air capture, and that's great. That's effectively taking carbon dioxide and removing it from the air. That takes a lot of energy, but it can be done. And equally, direct heat. We can use the heat from a nuclear reactor straight into a plant for glass manufacturing, paper manufacturing, energy-intensive applications, or to heat our buildings. So the reason I wanted to show you that was because at the moment, that's what people think of for nuclear. And that, remember, is only 18%. If we can decarbonize electricity, that's great. The other 82% is effectively down the right-hand side. The industry applications, the transport applications. And nuclear can help with all of them. In terms of hydrogen for our homes, I'm going to get into some numbers now to show you the scale of energy required. So our current gas network transports natural gas. We can transition 90% of that-ish, as it stands, to hydrogen. We literally just change the natural gas import to hydrogen. Need a lot more. Hydrogen has a lot less energy per unit, need a larger volume, but the process is there, it could work. And then like we've had our smart meters fitted, and the gas man could come in, take out the burner in your boiler, put in a hydrogen burner. Or a whole new boiler can be installed when yours comes to the end of its life. And we are investing in this. There's hydrogen homes across the UK and various trials. In terms of the energy required for the gas network, it's about 760 terawatt hours. That's more than double our current electricity generation or consumption in the UK. So heating, we could say, if we assume that all gas in our pipes is for heating, heating is double, at least, the energy we use in electricity. Just to give you a scale of comparison there. To compare now to transport, we measured transport in million tons of oil equivalent. That means nothing even to me. So what 1 megaton of oil equivalent is the equivalent to 11.63 terawatt hours of energy. So let's just take that top line, petroleum for road. In 2000, and what year have I used? 2019, we used 39.1 million tons of oil equivalent for petrol for our roads. To compare that to electricity grid, 334.2 terawatts. In petrol or petroleum alone for road transport, 455 terawatts. The whole electricity grid for the whole UK, 354 terawatts. I'm just trying to get into the scale of the challenge we face. So now let's pop back to a chemistry lesson again. We had this before. I was explaining how we take this carbon and then we release to the atmosphere. The locked away, quite safe carbon, released to the atmosphere. Now, I'm going to suggest now we take that hydrogen, that water, and that CO2 we released into the air. I'm then going to suggest that we do what I talked about, direct air capture, and splitting your water into hydrogen and oxygen. I'm then going to suggest that we stick them together, Fischer-Tropsch process, energy intensive, but it works by taking hydrogen and carbon dioxide, it reacts them together, and it forms hydrocarbons, and again, releases oxygen. And that then forms synthetic hydrocarbons. Now, you might be wondering, why am I taking us through this cycle? And the answer is, when it comes up, it is a cycle. We can use water and carbon dioxide, two things we've got lying around, we can split that up split the water, into the hydrogen, and we can use that CO2, and we can then react them together. Fischer-Troppick, again, GCSE science process you learn about, to make synthetic hydrocarbons. Why do we need these? Well, the problem is that fossil fuels are extremely energy dense. We fill an aeroplane, very heavy, with hundreds of people, if not thousands of the A380s, and we send them across the globe a long, long way. And that's just with 2 wings full of fuel. If we did that with electric, there's no room for the passengers or their baggage for their holiday. Cargo ships, if we did it to cargo ships, there's no room for the cargo. It kind of defeats the object if you've got a cargo ship just moving around with just batteries in. But if we can make the fossil fuel, effectively, the hydrocarbon, and have this closed loop, we can use our current transport assets, so our current jet airlines, our current cargo ships, and we can have this closed loop. It's sometimes called drop-in fuel for the exact reason that you can literally drop it in. The same petrol station, effectively, could give you the fuel. Now, I'm not suggesting that all our domestic cars go to synthetic fuels, because that is an energy-intensive process. To make that energy, you'll all know, energy can't be created or destroyed. So to make energy-dense octane in this case, you require a lot of energy to go in. But if we want to still have jet airlines that go across the globe, we want to still have cargo ships that plow millions of tons of imports and stuff around the world, we need something which is really energy-dense. Another option, there's more nitrogen in the air. You can make what's called ammonia, NH3. Again, just another example of a process which we can use as a circuit. So you kind of get in that case, you're getting your water, splitting it, get your hydrogen, getting your nitrogen from the air, reacting them together in Haber-Bosch, and you're then making ammonia. Another closed loop. So the purpose here of going through that bit is to say that, look, fossil fuel that we get out, and we're using a lot at the moment, we can actually make that using what we've got, and that would then be a net zero carbon cycle. Right, I'm going to get you to answer a question for me now. So this is electricity consumption and how it was generated in 2019. The red ones are the fossil fuel generating forms of energy. The rest, or the ones with the green circle, are the clean, low carbon forms of energy. What percentage-ish do you think that is? So just to read it out for you, the top 2 come to about 140 of 323, and therefore the bottom come to the remainder. What proportion-ish is 140 of 323? Anyone do a simple? Emma, the Keswick maths teacher. Yes, 50%, just over half actually, I think, if you add it up to the exact decimal points. Just over half electricity in the UK is low carbon. Brilliant. We're halfway there, and that's a lot further than we were 10 years ago on electricity. However, those numbers I was calculating before, the 760 required for heating, and then I did lots of calculations which have been independently checked, saying, let's assume all our passenger cars we use become electric. Let's assume that all diesel taxis and stuff become hydrogen. Let's assume that the remaining trains on the kind of branch lines become hydrogen. Let's assume that the planes become synthetic fuel. The energy required, if you do all the assumptions, comes to that 1,133 terawatt hours. So the next question for you is, what percentage of the total energy demand is currently produced from low carbon? So what percentage is 140-ish of adding up all the numbers on that right-hand side, the 1133 plus 760 plus 323.7? I got it as 8%, but yeah. What I'm trying to show here is we are 8% of the way towards net zero as a country. That's worrying. 2050 isn't actually that far away when we're 8% of the way there. We're 50% of the way there with electricity, and that's what the people, media and stuff will have you believe, isn't this great, this is good. How on earth is the other 92%? The energy-intensive bits, the bits you can't just connect your power cable up to your plane across to America. And that's what I'm trying to get across, is what huge challenge we face. And remember, that's just the developed world, or just the UK. To give you an idea, land area-wise, that still might not be quite easy to picture. That doesn't actually come up too clearly on this screen. That little dot in Cumbria is 55 kilometres squared. A company called Lucid Catalyst did some calculations. If you assume that what land area is required for the current UK oil consumption, effectively, via wind, solar, and advanced heat sources, aka nuclear. 55 kilometres squared would be required to do all of that from advanced heat sources, 26,000 from solar, and if possible, if you could do it like this, 136,000 from wind. What does 55 kilometres squared look like? That's about 1.6 times the current land area of all 6 oil refineries in the UK. So you're not talking a large area, really. And that's just to give you an idea, because it's how do you picture how much energy is really required. So if we are only 8% of the way there, can the UK achieve it? And the answer is yes, if we treat it about it with COVID. That was an emergency. Look how we got regulations through for the vaccines. Look how we moved as a planet in that case. If we treat this climate emergency in the same way, it is achievable. But that will require immense amounts of innovation, immense amounts of storing energy, and it will require things like using more tidal. God gave us 2 tides a day. That's 4 tidal movements. We all know the power of water. Imagine if you could harness that water coming in every 6 hours and then out every 6 hours. Yeah, twice a day. That's a lot of energy. We're a little island. Imagine if we could get the innovation right with tidal to really harness all that power. Imagine if we did have, as the video said, solar panels on all our houses with storage. So tonight you could still be watching EastEnders or whatever, or sat in here in church, because we could store that energy. And obviously we also require, well, as I kind of come into, nuclear energy to be part of this. So I'm not advocating for just nuclear. We need every single form of clean energy we can, and all the forms of storage we can. We are blessed with salt caverns in the UK. Salt caverns are a great store of hydrogen, and for carbon as it happens. So we could be using all the forms of energy in the summer when we don't need as much energy to then store it as hydrogen in our salt caverns. We need immense amounts of innovation to get all this to happen. But if we really treat it properly as an emergency, we can get, as a country, to net zero 2050. But that's only as the country. I'm going to pause again now and let 2 of my friends say how clean nuclear is.
I think for me, the moment I realised that I wanted to work in the nuclear industry was when I was sort of assessing how do we actually get to net zero? How does the world get to net zero? And right now, the only viable option includes nuclear power.
All sorts of different scientific bodies have shown that pathways to net zero require a lot more nuclear. We've kind of come to this from a very scientific standpoint. We're not saying that we think net zero needs nuclear, we're giving a voice to the real scientists out there who've done the modelling, who've done the hard work and found that net zero does need nuclear.
We will not get to net zero unless we embrace nuclear, and that's one of the reasons why we've developed our Rolls-Royce SMR technology, is to contribute. This is a very purposeful industry, and our outcome that we're focused on is about changing the planet. It's as bold as that.
Nuclear is one of the safest forms of energy, and much, much safer than the real issue, fossil fuels. We need to get ourselves off fossil fuels and use things like wind, solar and nuclear.
Another break for me for a minute there. So the thing you're all going to be thinking, so Aaron and Ailey mentioned there about, it's not just us in the nuclear sector that say we need nuclear. All the calculations and the different pathways say to get to this amount of energy needed, we need nuclear. But you're going to be thinking safety and waste. Understandably, it's a concern I have as well. So let's just touch on those for a moment. This is a graph produced by Our World in Data, not a nuclear organization. They take all the data and they then work out stats. In this case, safest and cleanest. So we're all aware coal and gas, they're not the safest of industries. They cause a lot of secondary illnesses, lots of cancers, lots of other issues, and equally greenhouse gases. It's huge. The key thing here is that nuclear, even including the deaths of Chernobyl, is 0.03 deaths per terawatt, what unit we're in here, terawatt hours of annual generation. It's a safe form of energy. The media will have us believe it's not. But equally, when a plane crashes, it makes lots of media news, but that's far safer than driving. It's similar here. The way the media portrays it versus the actual accidents we have and the safety of it, and this isn't nuclear data, this is data done by Our World in Data, they're independent. And in terms of carbon emissions, it's about, when you think of the whole life cycle, so obviously you do need some concrete, you need some transport, it works out about 3 tons per gigawatt hour of energy generation, which is actually cleaner than wind and solar when you think of the life cycle of energy, carbon emissions through the whole life cycle. That's probably news to most of you, how clean and how safe nuclear is. And that's part of the challenge. The messaging we have and the people that we have giving it to us would have us believe, actually, nuclear should be where coal is. It's dangerous, it's carbon emitting, it's bad. No, nuclear isn't. Nuclear is clean, and it is a safe form of energy. Waste. Waste is a challenge. We have sat down the road Sellafield. And Sellafield, we have to remember, was built for the reason of an atomic weapon. That's why they wanted to build it. And they happened to have this power that they wanted to give away. And you may remember the people that are slightly older in the room, the too cheap to meter concept came out. What is at Sellafield is not acceptable. We would not do that today. The way we have effectively pushed everything under the carpet in the 50s, 60s, 70s is not acceptable. We now, as our generation, are dealing with that, but future new nuclear will not be managed like that. We won't. We know how to manage the waste. We know how to size reduce it and plan it to be disposed of. We would not just throw it in a big swimming pool and leave it without an inventory for 30 years. And I don't mean to be dismissing some of my grandparents that did work there then. What they did was for a reason, but they did not have waste management in mind. And we are now learning, we now have that challenge to deal with our generation. But when we think about the mass of nuclear waste and the volumes, in terms of what's currently in stock, the next 100 years is about 5.1 million tons. That sounds quite a lot, but 5.3 million tons of hazardous waste is produced every year from households and businesses. We throw batteries in the bin. We throw other stuff in our bin. The bin man comes once a week, or bin woman. It disappears. We accept that. Where does it go? We don't know. But that's going somewhere, and there is hazardous waste in that. But we accept that. We do not want rats in our back garden and leaving all our waste piling up. We just say, take it away. In terms of what the volume of 4.5 cubic meters, which is the kind of total volume this would equate to, it's about the size of Wembley Stadium. Key thing to note here is most of the dangerous, sort of highly active waste is a very small volume. In terms of the graphic, you can see there of the skip, the amount of radioactivity is large in the smallest volume to the bottom of the graph, bottom of the chart, and then top obviously shows the opposite. So the protective equipment you wear, that sort of stuff that decays away quite quickly, that you have rig and other sort of low-level repositories, that's the majority of the waste. There's a very, very, very small amount which is high-level waste. What do we do with this? And this is what you may have heard about the geological disposal facility. It's been discussed about being put here in Cumbria. It is a highly engineered, underground, safe vault, effectively, for nuclear material. We will go down through tunnels, a long way down, and we will have these vaults where you then put the nuclear waste, and it will remain there as it decays away. Nuclear waste, opportunities for it. So I'm coming towards the end here, 2 more bit sections. Nuclear waste actually offers us a benefit. First one, oh no, let's do this again first. I've discussed all that stuff on the left top before, but that nuclear radiation can be used. Health and nuclear medicine. We're probably all aware of radiotherapy that's used to help with cancer. Well, it's therapeutic and diagnostic. So sometimes you drink something, it's a bit radioactive, you see where it goes in the body, it decays away. And equally for therapeutic, you can target the cancer cells. At the National Nuclear Lab, we are involved in looking at what's called targeted alpha therapy. That is taking your bit of radiation and sticking it to something which will seek out the cancer. So it's not like sending lots of radiation at your body from externally. It will go in and it will target just the cancer cells and kill just the cancer cell. This is taking nuclear waste, separating out particularly what's called isotopes, and they can be used to treat cancers. And that's, as you can see there, it's made a news article, and it's making multiple news articles across the world using nuclear waste in this way. The other one is space, in terms of we have used radioisotopes in space for a number of decades. Space is quite cold. Space gets dark every now and then if you're on the sides of planets. We can use nuclear material either as a hot water bottle electronics don't like getting too cold, to keep it warm, or as a power source. We can move Mars rovers and stuff around using a nuclear material. Another short video about some work NNL.
As space agencies around the world hunt for new power sources, the National Nuclear Laboratory has identified Americium-241 as the fuel that will power future exploration for hundreds of years.
We define ourselves by our big ideas, our light bulb moments. The discovery that nuclear waste from our past can become the fuel of our future.
A team of scientists has separated americium from the plutonium stocks and safely turned waste into power.
Hard work, sleepless nights, ideas powered by critique and analysis.
An exact process that dissolves, separates and extracts these elements to create a source of energy that works in the darkest extremes of space.
Then finally, breakthrough.
Americium will power the deep space probes of the future, operating far from sunlight where current technologies fade.
We never give up on our insatiable drive to explore our solar system and beyond, to push the boundaries, to look further, search deeper.
And opening up the potential to better understand the future of our people.
Our beginning is already here. But our destiny lies out there.
That's just two examples of how nuclear waste can be used in space applications, and a very important one, health and nuclear medicine. At the moment, we import a lot of our radioisotopes we use for medical purposes, and it is limiting how much we can use to treat people. 1 in 2 of us will likely need therapy at some point. At the moment, we have to import all that. Imagine if we could use nuclear waste to make those isotopes. The final bit, advanced reactors. So at the moment in the UK, you may have heard of Hinkley C. It is a humongous engineering challenge. The biggest crane in Europe is sat down there in Somerset at Hinkley C. It looks like this. It is a big construction site. Thousands of people descend on Somerset for a number of years, and they do all the big concrete, big pours, big work. It's a huge upheaval, effectively, to community. To give you an idea, that little bit on the side is a football pitch. Shows you how big the site is. Lots of buildings, lots of engineering, as I mentioned, lots of people coming to site. What we're doing now is a form of what's called modular reactors. So I'm going to talk us through this video rather than someone else talking. I'll talk over this. But this is Rolls-Royce. You heard from someone called Tom Samsung in the video earlier on. He is the CEO of UK SMR. And UK SMR is a way of building what's called these modular reactors using car manufacturing sort of techniques of factory builds. So the whole aim here is a central location, let's hypothetically say Birmingham, has factories that are building the modules for nuclear reactors. So rather than having a community where you have thousands of people coming for 5 years and then effectively all deserting it and only a few hundred remaining to operate the plant, you have a production line, like a car production line, which makes the various components, the various modules for a nuclear reactor. As you can see here, it kind of goes on the production line and the various bits are added. And then workers kind of check the bits, add the bits, and you've got that stable workforce in a stable location, not moving across, not your welders suddenly going to Somerset, then your welders going to Anglesey. And then also you can do all your checks there. So here you can see via various lasers and stuff, you can check, is everything correct? You can do a lot of your safety tests because you've got those repeatable modules being made at a factory. And here's an example of kind of making the reactor pressure vessel. Again, you can do that via a modular technique. So you again have all the safety stuff, one place, testing it, repeatable. Every single module, like with cars, comes off identically from your production line. You then, as you'll see in a second, put it onto your lorries, and your lorries can then transport this across the UK. Or, going back to my developing world point, you could put these modules, the small ones can be an ISOFreight container, so the shipping containers. Imagine if you could send a shipping container across to somewhere in the developing world, you plug it in, and that can offer energy for them to have clean water, have 24/7 electricity, and a number, you might have heard Sustainable Development Goals. A lot of what nuclear can offer is a lot of the SDGs, Sustainable Development Goals. Now, I'm not suggesting we just literally send it on a ship over to the developing world and leave it there. It will require some trained people to go with it and to make sure it is managed, but that sealed unit, that sealed container, could go across and be operated for decades. Or in this case, you can build it on a site, let's say near Sellafield, and you have your various modules coming. So you have tens of people rather than thousands of people coming and doing up your bolts like a Lego model. You're not starting literally from every single individual bit of plastic molecule. You've got your Lego bricks. It's the same here. You have those modules, you stick them all together, and you then have a reactor. And these can be scaled up and down. There's one being developed by Urenco called U-Battery. That is a very small reactor that could be used to kind of just produce energy for a particular industrial hub. Let's say Iggesons down the road or something. Could have something like that sat there. Or you can have the bigger ones like UKSMR, which are used to power either bigger districts, cities, etc. So this is coming to the end now. I've gone through that pretty quick. There's a lot of material there that I've gone through tonight. But the key thing I want to get across to you is in the UK, we are 8%, as it stands, of the way there. If our flights go up at the level they've been going up over the last 15 years, we're not 8% of the way there. If we keep building the way we're building and our new houses, we're not 8% of the way there. God's entrusted us with this planet. At the moment, we are treating it like the burning side of that globe being held. We need to invest in every single form of low-carbon energy, which does include nuclear. Ideally, yes, if we could harness every single ray from the sun and every single bit of energy from the tide, that would be great. And if this technology lasted for hundreds of years, but they don't. So if we want to continue with the way we are behaving as a planet, but equally, developed world deserves clean water. They deserve energy. That requires even more and more energy than we are generating at the moment, and it all has to be clean. So I want you to just reflect on that while we now watch the flash mob, which we did up in Glasgow in November 2021, or the end of the flash mob.
We need a zero. We're holding up for a hero to deliver this right. It's gotta be safe and it's gotta be clean and it's gotta be up to the fight. We need a zero. We all know that it's nuclear to get this right. It's gotta be clean and it's gotta be soon and it's gotta help keep on the light. We need a zero. We're holding up for a hero to deliver this right. It's gotta be safe and it's gotta be clean and it's gotta be up to the fight. We need a zero. We all know that it's nuclear to get this right. It's gotta be clean and it's gotta be soon and it's gotta help keep on the light. Keep on the lights.
So we are the Nuclear Institute Young Generation Network. We're a group of young volunteers who are really passionate about advocating and inspiring for nuclear power as a way to help deliver net zero. You can find out more about us on the website www.netzeroneedsnuclear.com.
So my final leaving thing is embrace, engage, enable. I use this a lot when I talk to graduates and a lot of other people. I have shared the challenge we're facing. I have shared my frustrations with the media and how they kind of portray nuclear. I'm asking you now to embrace this. If we want that clean planet, we want to go more from 8% towards net zero to 100% in the UK. Oh, and at the same time, help the developing world. We need to embrace this. We need to, as the Christian Aid videos said, speak to our politicians, speak to those that can make a difference, speak to the people that have got the purse strings, to engage with it. And then, as a planet, we will enable net zero. We won't end up having other people that can't grow their crops, that will starve, and the clean water issues we've got at the moment, and the flooding. Because only then will we be able to keep the planet at the current temperature, and we'll be able to protect it for future generations. Otherwise, it will be like the other side. Thank you. I have open to questions now.
I can hear myself now, that's okay. So that was very informative talk, Robert. Thank you very much. I was looking for mob at the end, but you weren't there. Right, so has anybody got any questions? If you just put your hand up or come around with a mic and everybody can hear the question then if you speak into the mic. I've got a question then. Oh, no. Well, we'll go for Roger first.
Sorry about that. Making you walk all this way with a bad foot. Thank you very much, Robert. Just on the waste issue, what sort of percentage of the waste would you say is from the nuclear bomb as opposed to power generation? Because people have told me the vast majority is from the nuclear bomb process, not actually from power generation. Is that true?
So in terms of Sellafield, almost all of that is because of the waste produced as we were trying to make the atomic bomb. So yes, in terms of value chain, kind of end chain cradle to grave, what is the waste product from making the bomb? That's sat down the road at Sellafield. So in that respect, yes. Which is why I said we need to treat the future nuclear reactors as almost a new way of doing nuclear, because we will not be racing to get that atomic bomb and therefore getting all this waste at the side. We'll be managing it very carefully, we'll be segregating it, we'll be working out what is the dangerous stuff and he's managing differently, what can just be sent to more traditional landfill sites and stuff. So yes, you are right, from a value chain, a lot of what we've got down the road is from the atomic war.
Thank you very much, Roger. Have we got any more questions? I'll just go to the back for Wendy, and then I'll go to Terry, and then Adrian.
Mine's not so much a question, well, there's two. A statement of when I watched that graph of the number of flights and the way that we're increasing the flights. Very interesting to see what happened in COVID, and we all sat outside with clear blue skies, the birds singing wonderfully, and there were no flights. Yeah. And no traffic on the roads. And I just think that is a really important thing, that somehow we need to grasp that and what that says to us about what we're doing. And then my other slightly more controversial thing that you won't be able to answer in a way is, but after watching your presentation, which I thought was amazing, well done, Robert, that was fantastic. And when you talked about how much money it's going to need to spend on this new development, and the amazing things that it can do, why on earth are we wasting billions on HS2 that's going to get us nowhere? Sorry, but that's a bit political, but I think there's a real issue there, is where are we setting our priorities?
Yes, I couldn't disagree. Living in West Cumbria especially, we're not going to benefit much from HS2. But yeah, where government spends money, where we invest it, what happens, yeah, that's why we need to be the ones with the voice that we use to our MPs. And if we say to them that, we get to the next election, who you vote for is going to relate to what the party you're talking about, in my opinion. So if they're going for HS2 or investing more in energy storage, clean energy, nuclear, wind, solar, tidal, I know what I'm voting for.
Right then, we'll go for Terry then.
Thank you very much, Robert, for your talk. It was really, really interesting and well done. I was listening to the radio yesterday about carbon capture. So could you just explain a bit more about that? Because there was a thing on saying, you know, you could turn it into baking soda. Yeah. And the sea was full of baking soda, and I thought, that's losing me a bit. Yeah. If you could explain that.
Okay. So the air around us is about 78% nitrogen, 20-ish% oxygen, a little bit of carbon dioxide. We obviously all breathe in oxygen, and our body does stuff. We breathe out a bit more carbon dioxide. So generally, if there's a human living, we effectively are emitting more carbon dioxide than we're breathing in. So when we go back to that net zero thing, it's not zero carbon, unless you're going to kind of stop breathing, which I don't suggest, we're not going to get to zero carbon. But what we're suggesting is a way of getting to net zero is that you can still have some carbon-emitting forms of energy. I love steam trains. If we suddenly turn steam trains into electric, it kind of loses something. So what you can do is this carbon capture. So when I mentioned synthetic fuels, what you're doing is you're taking your carbon dioxide, or the whole air, sorry, you're putting it through what we call a scrubber or some other sort of process where chemically you're separating it. So you've got sieves at home and you're sieving out something. Effectively, it's a chemical sieve. So you're therefore using a chemical process to strip the air of carbon dioxide, and then obviously what comes out, the exhaust effectively, is just the oxygen and nitrogen. And that carbon then, you can then kind of capture separately and use. Various ways of using this, so you can stick it back under the ground, salt caverns like I mentioned, or one way is the sea itself. So there's talking about, how you can, and I heard of it on Radio 4 as well, how effectively you can transfer it into a form of baking soda and then put it into the sea. I hadn't heard that until yesterday. We don't know much about it, but it is a way effectively of using the sea as a carbon store. So it's just a way of you putting that carbon somewhere. There's various other ways of saying if you put enough pressure, it can become a liquid. So again, you can then use kind of where you got fossil fuel from. So you've got your crude oil coming out. Theoretically, you could pump your carbon as a liquid, carbon dioxide, under enough pressure back into your oil wells, are they called, whatever they're called. So does that answer your question on how carbon?
Right, Adrian?
Thank you. Yes, I suppose just some reassurance, really. Just in that, I suppose we're all aware of the sadness of Ukraine and including a nuclear power station under attack. And I suppose it's the geopolitics side that, you showed videos of next generation nuclear power stations getting exported on ships and so forth. Is there anything less dangerous about smaller next generation ones if they get in the wrong hands than current ones?
So, very interesting question. I suppose in one way, you've got your one ISO freight container. So you're all aware of cash machine, the cash vans that turn up at shops and the man goes in with his motorbike helmet on and comes out. That van, effectively, is a safe. So that as itself, as that unit, is safe. And some of these units, we're making the ISO Freight Light units, the amount of lead and other security around it, all you have is the one wire coming out effectively that you're plugging in. So in that respect, it's safer than things like having all the various separate buildings and separate containments and things. The new regulations in the UK we have, the Small Modular Reactor has to stop a 747 flying directly at it. That's one of the kind of criteria. So effectively, are we creating, is it more risky? No, definitely not. Is it a risk, I suppose, exporting it? If it got into totally the wrong hands, so someone that actually wanted to constantly be firing at it, then eventually, yes, it would give way, like everything. But they are built to be safe, protected. The regulation requires them to be extremely safe and impenetrable from various forms. So I'm not suggesting that we just literally just send it off somewhere that wants to purposely kind of dig out the radiation in it, but they are designed to be safe and to stop sustained attack.
Thank you very much. Has anybody else got any more questions? Anybody else? I might ask you mine then, Robert. Yes. Lots of what you've proposed use rare earth metals, which are mined not necessarily in environmentally considerate ways. How do you envisage, and how do the nuclear lobby envisage doing this in a sort of more sympathetic manner, especially to sort of indigenous populations that are really affected negatively by that?
Yeah. So you're right, rare earth, especially in solar panels and stuff, there's a lot of them. And the recyclability of them, it's a challenge. Electric batteries, the same for the cars. In terms of uranium you can actually extract from seawater as well. So there's multiple ways, as well as mining it, we can find other ways of getting our uranium. In terms of how we protect the indigenous populations and stuff, I've not really got an answer directly on that. I think we have to work with them. I think we can't just kind of go, we're coming in and dig up where they are. I think we work with them, and we have that working as a globe and thinking about these sustainable development goals and the planet as a whole. If we're working with them rather than enforcing it on them, there's that relationship building and trust, I suppose, as well. But you are right in terms of the solar panels and the batteries. They are very reliant on rare earth metals that are rare, hence the name, and do require a lot of mining to get very small amounts of material from it. But more nuclear would help.
Right, thank you very much. So with that, I think we'll just say a big thank you again to Robert. So if we could give him a big round of applause, people.
One last thing. If anyone wants to read about nuclear, there's lots of books out there. This one is called Power On, A Beginner's Guide to Nuclear Industry. It's designed for Key Stage 3, this one. but there's lots of various books for different age groups out there. I can't think of one that's designed just specifically graphically like this for the sort of 30s, 70s age range, but there's lots of books and stuff out there.
Right, thank you. Well, yes, this is a Christian Aid event, and so I'm just mindful that I didn't mention earlier about donating. So if you are able to donate, there's red donation things on various tables around the room, but also the next Lent event is on the 17th in the Hub, is that right? And it's Lynn Andrews? Graham talking about... So I hope that you people can go along to that as well, because I'm sure that's a daytime thing though, isn't it? In the morning. So thank you very much everybody for coming. And do I need to mention anything else? I would like to just pray, if that's okay. If we can just, if anybody else wants to pray as well, just feel free to come up and join in. But Heavenly Father, I just want to thank you so much for bringing people here tonight to listen to Robert's message about energy and the future that we have here on earth. Lord, I pray that you will just put it on our hearts to think about those who are less well off than ourselves, both in terms of climate justice and in their energy consumption and stuff like that, Lord, so that we might just make changes in our lives and make bold decisions about contacting people like our MPs and other campaigning bodies to make changes that we know can help people find justice, the justice that Jesus talked about in the Bible. Lord, I just pray that you will fill us all with the Holy Spirit and help us make good decisions about this emergency. Amen.